Algebra 1, post-chapter 10 worksheet, day 2. Again, what you should do is download this from my website and kind of practice along with me. I'm going to partially fill it out, and your homework is to completely fill it out, do the problems that I did not. You should remember from chapter 10 that we have something that you could call factored form. I may have mentioned that in one or two of the videos from chapter 10, but I didn't focus on it. We know what factoring is. It's just the case that there really are three forms of quadratics, three common ways to express a quadratic. One of them, standard, that's what's really focused on in chapter 10. One of them is vertex form. That's what we focused on in part on worksheet 1 here, the previous lesson. And then there's also factored form, and you know what factoring is, so that would be what all of these problems are here that you're looking at on the screen right now, numbers 1 through 6 on the worksheet. So let's do number 1. And it says graph the function and then label the vertex and the x-intercepts. Now, I'll say that if you followed along with the factoring and with what we call the zero product property in chapter 10, I believe that was section 10.4, if you wanted to go back and look at that. What you should be, well, let me just back up a second. Factoring was in chapter 9. We hit that skill very hard for about 4 sections in chapter 9. And then in section 10.4, we used that skill in order to solve a quadratic, okay? Well, now we're not solving quadratics because now you have two variables. Back in section 10.4, you would have been given something that was a quadratic that was equal to 0, or that you could set equal to 0 and then factor what's equal to 0 and then use the zero product property. In the same way here, I'm going to use the zero product property to find the x-intercepts, okay? Now these are also commonly called roots and zeros. Specifically for a graph, it's called a zero because it crosses the x-axis. That's where the y value is actually 0. When you're solving an equation, it's known as a root. And back to the graph, we could also call them x-intercepts. That's what this is calling them here. Okay? So all that to say this. You ought to be able to look at this at this point, I believe, a simple one like this and go, okay, -2 causes this to be 0. +4 causes this to be 0. Okay? What the proper use of the zero product property would have you go, okay, x plus 2 equals 0, and then solve that by subtracting 2 from both sides, and you'll get x equals -2. X minus 4 equals 0, in which you could solve by adding 4 to both sides, and you'll get x equals 4. But is that really necessary? Do we really need to go through that process? I think you don't. Whoops. I didn't know that would happen. I think you don't need to do that, but rather you should be able to just look and go, okay, -2 causes this parenthesis to be 0. There's going to be a 0 at -2, and I'll plot that point. +4 causes this parenthesis to be 0, and I can plot that point. Okay. Now that's what I'll say is 2 of 3 points I think that are necessary for drawing an accurate parabola in this context, which is find the x-intercept and then label the graph the function, label the vertex and the x-intercepts. So what's the other thing would be to find the vertex, obviously. Okay. Now, what could we do? Maybe even pause the video right now and think, what if this were a quiz test question or a PSAT question and you had to find the vertex? What could you do? Someone may say you could change it to standard form and calculate -b/2a. Absolutely, you could do that. You could do that, and that would be correct. And you would find the x value, in which case you could plug that back in for x, and you could find the y value then as you just plug it in and do the arithmetic on that. Someone else might say, well, you can convert it to vertex form, and then we can just pick the vertex out of vertex form. And that would also be correct, except at the moment you don't know how to convert from one form into vertex form. In fact, that's the back page of this very worksheet that I'm going to show you how to do that. But that also could be done. I think the best way to do it, and maybe this is the most logical way, maybe the one that you thought of, would be to just go halfway between these 2 points. You know that these 2 points are symmetrical about the axis of symmetry. So if I've got one at -2 and one at +4, there's going to be an axis of symmetry right here at +1, as in the equation of the vertical line that is x equals 1. Okay, so that's a 1. And what would we do with the 1? I know the vertex. The vertex is going to be 1 comma something. Well, I could find the y value by just plugging 1 in for both x's. And 1 plus 2 is 3. 1 minus 4 is negative 3. 3 times negative 3 is negative 9. The vertex is at 1, negative 9. And had you used the other two methods that we mentioned, you will still get, if you do the math right, 1, negative 9. So we want to plot that, 1, and then 1, 2, 3, 4, 5, 6, 7. Oh, so we're just going to be just off the graph if we go by ones, which I think I will do. You could certainly change the scale. I mentioned in the last worksheet, if you did that, you'd want to put a scale on here. So you could still go by ones on the x-axis, 1, 2, 3, 4. There's one of your x-intercepts. But if you went by twos, then it'd be negative 2, negative 4, negative 6, negative 8, negative 9 could be here. But do make sure that you put a label on your y-axis if you're going to do something like that. And then you could just draw the parabola. Pardon my my drawings here. I'll do the best I can, but it's somewhat hard to do this on this computer screen. Try to draw a curve. Okay? Now, numbers 2 and 3 are very similar to number 1. Number 4 is also similar to 1, 2, and 3, except notice that negative out front. So be careful with that as you do that problem, because you will have a parabola that opens down instead of up. All of these will open up, but that one will open down because of the negative. You'll see it happen if you do it right as you find the x-intercepts and the vertex. You'll find a couple x-intercepts on the x-axis, and then the vertex will be up here. Okay? And number 5 would be similar as well to 1, 2, and 3, so I'll leave you to do that one as well. That 3 is not going to really affect too much until you go to plug in for the y value. So you'd have x-intercepts of 1 and 4. Okay, I'll just give that to you. 1 and 4, go ahead and find the vertex, and do incorporate the 3 into the y value of the vertex. After you figure out the x value, plug that number in, and then just do the math all the way across. I do want to do number 6 because this is one that will confuse some people because it doesn't look like two binomials multiplying like the other 5 do. Bottom line is, though, we're still going to use the zero product property, and it would be negative 7 that causes this to be 0, and it would actually just be 0 that causes this factor to be 0. This is like the factor that is negative 3x plus 0. Okay, we just don't bother writing plus 0, and then for that reason you don't have to have parentheses around it. But there are zeros here of 0 and negative 7. So I'll plot the point 0, 0, 0, and then 1, 2, 3, 4, 5, 6, 7 would be out here. That's negative 7. Okay, and then as I plug in, the difference, or the halfway point, I guess I should say, between 0 and negative 7 would be negative 3.5. So we're going to have a vertex at negative 3.5 comma something. Okay, and you do the math on that on your own if you like. I did it ahead of time, and it is 36.75. So that's the vertex, negative 3.5, 36.75. Okay, now with that in mind, you are not going to be able to go by ones. 36.75 would be way up here. So let's go ahead and go by 5s. 5, 10, 15, 20. Here's 25 right here. The 5th tick mark would be 25. And negative 3.5 would be right here. 36 would be, there's 35. So just above that would be 36.75. Do the best you can. Doesn't have to be perfect when you're plotting that, but that would be it. Okay. Now I just noticed that on my first one I didn't label the x-intercepts. So however you want to do that, you could label them with an ordered pair here. I'm just going to list them off to the right. So on this last problem it was negative 2 comma 4, and on this one it was 0 and negative 7. Those are your x-intercepts, and then the vertex is what I have there in parentheses. Okay, moving on. Write the quadratic function in standard form. Let's remind ourselves that standard form is y equals ax squared plus bx plus c. Okay? And if you just think in terms of simple orders of operation, you'll know what to do with this. You'll know how to make this look like this. Remember in the last video when I told you that the a value in vertex form, the number that's right here, will be the a value that's in standard form. So I'm telling you that after we do this, it'll be y equals 1x squared, etc. on this one. On number 8, it would be y equals negative 2x squared, blah, blah, blah. Okay? Because the a value in vertex form is the same a value in standard form. So what you would simply do is multiply x minus 2 times x minus 2, as in FOIL. And then we'll just leave that plus 6 there for right now. And that would be x squared minus 2x plus 4, right? And you can put it in parentheses if you want to, although all we're going to have to do now is simplify and add the 6 to the constant. So you really could leave those out just as well. And that's the FOILed form, unsimplified, of x minus 2 times itself, and then there's plus 6. So standard form would be y equals x squared. Here you have like terms, so minus 4x, and here you have like terms, so plus 10. Converting from vertex to standard form. Let's go ahead and do another one. Why don't we do number 12? We'll do the same thing with number 12. That's not in vertex form, that's in factored form. Now you can multiply this either way, and a lot of people will say they want to distribute in the negative 3 first. That's fine, but let me say this. If you're going to distribute in the negative 3, you don't think you're going to multiply everything by negative 3, do you? You can multiply negative 3 by this parenthesis, and that would be it, and then you could go ahead and FOIL the parentheses that are left. Think of it like this. If I said multiply 3 by 4 by 5, you wouldn't multiply the 3 by the 4 and then the 3 by the 5 and then the 4 by the 5, would you? And then add all that together or whatever, or multiply it? No, you would multiply 3 by 4, which is 12. 12 times 5 is 60. That's what 3 times 4 times 5 is. By the way, associative property, you could multiply 4 times 5 and get 20, then multiply it by 3, it's still 60. Okay? So in the like manner, what I'm going to do is, what I just said you could do, distribute in the negative 3, that's not even what I do. I like to just leave that alone and go ahead and do the FOIL of x minus 3 times x plus 2. That'd be x squared plus 2x minus 3x minus 6. And then distribute in the negative 3 to all of the terms. And I'm just going to put one arrow there because you probably can see that these are alike. So this is y equals negative 3x squared plus 2x minus 2x would be negative x, but that's also going to get multiplied by negative 3. So that'd be positive 3x. If you need an intermediate step in here to make sure you don't make a mistake, fine, please do that. Don't make a mistake. And then plus 18. Negative 3 times negative 6 is positive 18. And that's standard form. Okay, moving on to the next one. Find the vertex and state whether it is a maximum or minimum. Depending on the form now, and again, we'll just do a couple of these. If it's in vertex form, you should already know how to do that, right? That was worksheet 1. The vertex is going to be at 6, 3. Y equals a times x minus h squared plus k, where the hk is your vertex. Well, x minus h is x minus 6, so the h value must be 6. That goes here. Squared plus 3 when this was plus k, so the k value must be 3. The vertex is at 6, 3. Whether it's a maximum or minimum or not depends on whether it opens up or down. That is determined by this number right here, the a value, and that is positive, so it's going to open up, which means it has a minimum. Do we all agree with that? A vertex, a parabola that opens up has a minimum. It never gets any lower than this, right? Let's do 8 and 12. So, oh, I'm sorry, not 8 and 12. I'm in the wrong section. Let's just do 18. So that's in factored form. And to find the vertexes, I would do exactly as we did in the graphing problems at the first. There's going to be a 0 here at 3 and a 0 here at negative 2. I was thinking 2 and I wrote 3. Negative 2. And the halfway point, now those are the two zeros, those are the two x-intercepts, so the halfway point would be the x value of the vertex, which would simply be at a half, 0.5. Okay, so there's a vertex at 0.5 comma something, and you ought to be able to get that by just plugging in 0.5 into both x values and then doing the math. I've done that already and I got 18.75. Okay, and what about maximum or minimum? You see this is a negative sign out here. If we multiplied all this out, if we FOILed this and then multiplied in by distributing the negative 3, your lead coefficient would be negative 3. Okay, your standard form would be -3x squared da 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 da. Okay, so that's negative. That means that you're going to have something that opens down, which means it has a maximum, not a minimum, but a maximum. All right, so that's kind of the halfway point. The most important thing is what I'm going to teach right now. Okay, now first of all, here's the best news. 25, 26, 27, and 28, we are not doing these. You can cross those out. We will cover that in Algebra 2. We will definitely cover this whole concept in Algebra 2. 19 through 24 would be the simpler version. As soon as you put a number in front of x squared other than 1, it does complicate things and makes the process a little longer. But we're just going to get your feet wet here and get you understanding how using completing the square will do this. And then you'll be ready to go for this concept in Algebra 2. Okay, now I mentioned on page 1 that you can convert to vertex form, from standard to vertex form. And that's what we're going to do right now. If you've completely forgotten completing the square from section 10.5, it might be worth a quick look back to your homework or maybe the video or maybe just a couple minutes of the video to understand what solving using completing the square method was like. Okay, because now we're going to use that same method, but we're going to convert from standard to vertex. Let's do 19 and then I'll pick one more. First thing you need to do is get rid of the constant. In section 10.5, when we were solving using completing the square, the first thing you did was you moved the constant to the other side so that you could use the calculation for completing the square. I'm going to do the same thing here. Now, this isn't a 0 like it was in section 10.5 or some other number, but rather it's the variable y. So the left side of this equation kind of stands in like for storage. I'm going to add 6 to both sides just so I can move it, and eventually maybe we'll move it back. Okay, so there's just an equivalent equation. Now again, hopefully you remember the calculation b over 2 squared. This is how we calculated the number that we could add to a quadratic that wasn't a perfect square trinomial so that we could make it a perfect square trinomial. Okay, so that calculation here, the b value is the 4, the number in front of x is the b value, 4 over 2 squared. Well, 4 over 2 is 2, 2 squared is 4. So what are we going to do but add 4 to both sides? Caution, make sure you add it to both sides. Easiest mistake to make is to add it to the right, but to forget to add it to the left. If I add 4 to the right side, you got to add 4 to the left to make this y plus 10. And this is x squared plus 4x plus 4. Okay? Now, just exactly as we did in section 10.5, the next thing you need to do is factor this. The reason that you would factor it and the reason that we did the previous step is because when you factor this, it's going to come up to something times itself, some binomial in parentheses times itself. Okay? Guaranteed, because you did this calculation and added 4 to both sides, you now know that x squared plus 4x plus 4 is a perfect square trinomial, which means it's going to factor into something times itself. Something times itself, if I put a second set of parentheses here, better yet, I'm just going to put a squared. Okay? And that something is x plus 2. You see x plus 2 in parentheses times x plus 2 would be x squared plus 4x plus 4. We're just doing the opposite. We're factoring. And I don't know if you know it, but we're almost in vertex form because if you would now subtract 10 from both sides, oops. This is vertex form. That's the same concept of completing the square that we did in section 10.5, but now we're converting rather than solving. And that is in vertex form. The a value is 1. The vertex is -2, -10. Don't you see? X minus h squared plus k. Well, x minus h, and we have a positive here, would be interpreted as minus a -2. So the -2 is the h value, the x value of the vertex, which is h, squared, and then plus k, and here we have a -10, that's like plus -10. So -2, -10 is the vertex. In fact, the directions do say name the vertex. So it is -2, -10. Okay. One other thing when you're writing this in vertex form, I believe I mentioned this before, is it's really easy to leave the squared off. Just careless, and let's try not to do that. All right, so I want to pick one that's just slightly different than that one. Let's do 23. And then you'll be responsible for the other 4. So I'm going to subtract 3 from both sides. First step, get rid of the constant. And then we're going to do the calculation b over 2 squared to bring that back, to bring a constant back, but to make this a perfect square trinomial. So the b value here is -2. b over 2 squared would be 4. Now, coincidence that the last one was 4 and this one is also 4. But, oh, it's not 4. I'm crazy. -2 over 2 would be -1 squared would be 1. That's better anyway. We are going to add 1 to both sides. Don't forget to add it to both sides. Now you have y minus 2 is equal to x squared minus 2x plus 1. Again, you can be confident that x squared minus 2x plus 1 is a perfect square trinomial that will factor into something times itself, or better written as that something squared. And the something is a binomial, linear binomial. Okay, and it's going to be x minus 1. Use your factoring skills from chapter 9, and that will be x minus 1. The last step would be to just bring this constant back over, so you have y by itself. Y equals x minus 1 squared plus 2. And I think the others will work just like that. Oh, by the way, the vertex that they want would be 1, 2. 1, 2. All right, thanks for tuning in.